In this video, we're going to do a little Algebra 1 review and just kind of review how to write the equations of lines. So in this first video, it says write the equation of a line that passes through these two given points. And whenever I'm given 2 points in these type of problems, I'm going to label them as my first x and my first y, and then my second x and my second y. Just so that we don't get the points mixed up as we start to do this. And since this problem just says write the equation, it doesn't necessarily tell us what form to put it in. What we're going to do is we're going to write it in two forms. I'm going to write it in point slope, which is y minus y1 equals your slope times x minus x1. And then, but we're also going to write these into slope-intercept form, which is y equals mx plus b. And our route for doing this is we're going to be writing it in this point slope form first, and then coming to slope-intercept form. So as I said, our first step is we are going to go point slope. And so as I look at this, we have y minus y1 equals your slope times x minus x1. And what we're going to do is we're going to fill in a point for x1 and y1, and you can see that we have a point that would work there. But what we don't have is the slope. We need to figure out what the slope is here. And in order to find our slope, we're going to do y2 minus y1 over x2 minus x1, which is our rise over our run. So I'm going to subtract the y coordinates, y2 minus y1, which looks like to be y2 minus y1, over x2 minus x1. You have to be careful with your signs, x2 minus x1. And so my numerator becomes negative 2. My denominator, when I'm subtracting a negative, I'm going to add, becomes positive 6, and then that's going to simplify to negative 1/3. So if I copy down what I have y minus y1 equals our slope times x minus x1. Now what we're going to do is we're just going to take this point. It doesn't really matter which point I choose, honestly. Although I called this one x1, y1, I could have very easily called this one x1, y1. But I'm going to take an x and a y from a single given point and substitute in for the x1 and the y1 in our equation. So if I look here, it looks like our x1 is going to be negative 2, and it looks like our y1 is going to be 1. And so then our last step is we're just going to simplify that sign right there. I'm just going to change it to y minus 1 equals negative 1/3 x plus 2. That subtracting and negative becomes addition. So this would be your point slope form. Okay, that's the point slope form of the line. Obviously, if you put in this for x1 and y1, your form would look a little bit different here, but it would be describing the same line. Now what we're going to do is we're going to go to slope-intercept. And if you remember, our slope-intercept form is the form y equals mx plus b. So as I look at this, I'm going to start with my point slope form, which is y minus 1 equals negative 1/3 x plus 2. And what we're going to do is we're just going to simplify this and isolate the y, because once we get the y isolated, we'll be in slope-intercept form. So I'm going to distribute, and so I have y minus 1 equals negative 1/3 x, because negative 1/3 times x is negative 1/3 x. And then negative 1/3 times 2 is negative 2/3. And then our last step would just be to isolate the y by adding 1 to each side. If I have negative 2/3 and I add 3/3, that means I'm going to end up with a positive 1/3. So this would be, I probably should have been color-coded, but this is going to be our slope-intercept form right here. And this is going to be our point slope form. Now to this problem. This one is actually a little bit easier than the last one. It says write the equation of the line. Once again, we're going to do both here. Through 3, negative 5, and with a slope of negative 5, 6. So let's start with our point slope. So if we have y minus y1 equals your slope times x minus x1, what's really nice here is that our slope is given to us. It's negative 5, 6, and then we're only given 1 point, so we'll just label it as x1, y1. So let's just fill in the blanks. We have y minus y1 equals your slope times x minus x1. And so really you're done right, or actually let's go ahead and simplify. If we're subtracting a negative, that really means we're adding. So our equation is really y plus 5 equals negative 5, 6, x minus 3. That would be our point slope form. Now if we wanted to go slope-intercept, that would just be, we're looking for y equals mx plus b. So what I'm going to do is I'm going to start with my point slope. And we're going to do the same thing as last time. I'm going to start by distributing. So we have y plus 5 equals negative 5, 6x. And then whenever I multiply negative 5, 6 times negative 3, a negative times a negative is a positive. And this is really 5 times 3. We might want to just come over here and do this side. We're really doing 5 over 6 times 3 over 1. So when we multiply straight across, we have this. And I'm going to kind of copy up here. We got really one last step. So if I have y plus 5 equals negative 5 6 x plus 15 6, we just last need to subtract 5 from each side. And if I'm doing that, once again, our fractions are getting a little gross here. But if I wanted to come over here to the side and do this part right here, if I have 15 over 6 minus 5 over 1, I need to get a common denominator right here. So I'm going to multiply my numerator by 6 and my denominator by 6. So what we're really doing is 15, 6 minus 36, which would give us negative 15 over 6. I subtract the numerators and keep the denominators the same. So here is my slope-intercept form. In summary, I like to write the point slope form first and then just solve it for y to find the slope-intercept form. These are two different equations that describe the same line.